Hello, welcome back, guys. This is Surendra, and we are going to continue our lecture series of digital electronics. So, because of some reason, I was absent and I didn't have uploaded the video lecture. So, I will continue that lecture series. And till now, we have done the combination circuit, Boolean algebra, and number system. So, guys, and now I am going to start the sequential circuit. So in sequential circuit, what we have to read, as when we were discussing the combination circuit, I have given the little bit introduction of sequential circuit, as it is used for the storing of memory. So what we have, latch, flip flop, that will store 1 bit data, and we can extend to store many bits also. So this is the basic fundamentals of sequential circuit. We have to store the data. So in the sequential circuit, we will start with latch, and then move toward the flip flops and different type of flip flops. So in the latch, we have two type of latch. First one is AND latch, NAND latch, NAND latch, and second one is NOR latch. So NAND latch and NOR latch. So what latch is a circuitry which help to store the 1 bit number. So how latch look like? Like suppose I will give the example of NOR latch. So this is just one NOR gate, and here one more NOR gate. So this is the basic latch. So this helps to store the 1 bit data. Then how it helps, I will explain one by one. And what is the this S for set, and this R for reset. As we can predict by name, set means 1 and reset means 0. This is the only way. And in the latch, we have like the main disadvantage of latch is that for NOR and NAND, for both we have different truth table. So to eliminate this disadvantage, we will go toward the flip flop. This is called SR latch. So then we will eliminate that problem of a different truth table by SR flip flop. So this is the basic fundamental. Then we will go to the truth table of latch, how it generate, and we will see one by one. So guys, I have made it this circuitry of NOR latch, NOR SR latch. So here what this QN is, what this QN bar is. Here in the sequential circuit, we have two output. One is Qn and one is Qn bar. Both are complement to each other. As we have discussed in Boolean algebra, the bar shows the complement of that one. So if the Qn is 0, then it will be 1. If it is 1, it will be 0. If they are not complement, then that condition is invalid. That condition called invalid. So this is the fundamental. So we will take the value of S and R differently, and then we will see that what is the output when we will give the value this one, when we will get the value this one. So firstly, I will start with when S is equal to 0 and R is equal to 1. So this is the condition. I will show each and every condition. Don't worry. I have taken this condition because I want to show something. in next condition. That's why I have taken first condition as this one. So as we have seen that these two are complement to each other. And second thing is that the second thing is that how we have to solve this problem. Like this is this is the feedback of this one, and this is the feedback for this one. So how we have to take the problem? So first we will see that first we will consider that input which is disable input. What is the meaning of disable input? I think I have told in Boolean algebra. Disable input means, like suppose I am making the truth table for this one. So I have written the truth table for NOR gate. So what is called disable input? Disable input is that if we will give that input, then the no meaning of giving the other input, that always gives same output. So like here we have we seen that if we will give one input as one, then for sure the output will be 0. This will not see that other what is the other input. If other input is 0, then it is 0. If other input is 1, so then it is 1. So this is called disable input. This is called disable input. So when we will lead to latch, we will see that we have to see the disable input first. So the output is already predicted, then we can like do all the procedure. You will see. So guys, what if I have given 0 and 1? So as we have seen that in NOR gate, the 1 is disable input. So when here the input is 1, then obviously this will be 0 only. Then this 0 will goes here, and 0 0 will be what? 1. Okay. So this is the condition. This output will come here. There is no this condition is not depend on previous condition. Like previously, whatever the input is, whatever the output is, here the this same output will occur. So then we will see next condition as 0 0 both. What is the meaning of 0 0? 0 0 means we are not giving anything. So that means that if previously we have considered this condition, and the output is what? Output, suppose I am using different marker. I'm using different marker. Output were 0 and 1, as we have seen here, 0 1. So now if we are removing that in all inputs, so that bit should be stored. That means the bit should be same. So we will see that the bit is same or not. So here see that this 1 will come here, and 1 0 will give output as 0, and this 0 will come here, and 0 0 will give output as, see the truth table of NOR gate, 0 0 will give output as 1. So this is the same. That means if we are removing the output, it is storing the bit. So this is the basics of sequential circuit. So here this previously we have previous bit is this one, and this is coming as, if we are giving the input as 0 0, so then this is coming same. So we can say that when the S and R will be 0 0, then that flip flop will be no change. Like previously, whatever the data that latch have, similar output will occur in the output. So I wanted to show this condition, that's why I have taken first condition as 1 0. Now we will see other condition. So guys, this is the condition where I have taken 1 as S and 0 as R. So 1 as S and 0 as R. So what we know that this is 1 is disable input. So 1 is disable input. So this will give output as 0. And then this 0 will be here, and 0 0 will give output as 1. So here what we have seen that this is not depend on previous previous value means it is not using the value of this one. Whatever value we have previous, that will not, if we have given as 0 and 1, that will not, it will not use, it will obviously give the output as 1. So when we require the previous value, at that time when we have similar input, similar input, or both are 1 1, so both have disable, both have disable, or both are 0 0. So both, if both are 0 0, so we don't have any disable input. So how we will proceed? We will take the previous value and then we will move forward. So when both input are 0 0, then we will require the previous value of this output. And then next we will consider the R is equal to 1 and S is equal to 1. What happened? See, we know that both are disabled. Both are disabled. So whatever the input here, this is going to give the output as 1. And what I have said before some time, that these two output are complement to each other. So this condition will be the invalid condition. This condition we can't lead by latch. So what we have seen in SR latch, we will make one truth table, then move forward. Suppose here this is next output, and Q1 I will consider as previous output. As we have seen in 0 0, we have used previous output. So if S and R both are 0 0, what we have seen that the output will be previous. So Qn. If S and S is 1, S is 0 and R is 1, then this is reset, and then output will be reset, and means 0. If S is 1 and R is 0, then output will be set 1. Then if S is 1 and R is 1, this is invalid condition. So this is the truth table for SR NOR latch. So next we will see the truth table for SR NAND latch. So guys, what we have to see, the SR NAND latch. So what we have to see first we have to see that what is the disable input for NAND gate. So here see, when one input is 0, when any input is 0, any one input is 0, then output will always be 0. So here the disable input is 0 and 0 0 0. So first we will consider the condition when S is equal to 0 and R is equal to 0. R is equal to 0, S is equal to 0. So what both are disable input. Both are disable input means the output will give as 1 and 1. So this condition can't occur because both outputs should be complement to each other. So this is invalid condition. And second, when R is equal to 0 and S is equal to 1. R means 0, R means 0, then what we know that 0 is disable input. So first we will do this. So R means 0, this will always give output as 1, and this 1 will come here and this will give output as 0. So guys, now when R is equal to 1 and S is equal to 0, so 1, here we know that disable input is 0, so 0, this will give output as 1, and this 1 will go there and this will give output as 0. Then we will consider last condition. So here 0 and 1 and 1, sorry, 1 and 1. So we know that we don't have any disable input. So what I have said that if we don't have any disable input, then we will consider the previous, we will take the previous input. If suppose previous input is 0 and 1. Suppose previous input is 0 and 1. So what, this 0 will come here and this will give our output as 1, and this one go there and this will give output as 0. So what is this is similar as, if we will take 1 and 0, so this will give output as 1 and 0, do by 1. So we have done this thing in both SR NOR latch and SR NAND latch. So what is the difference between both? Why in the starting of I have said that here the disadvantage is that we don't have same truth table for both. So we need to look the circuitry, what circuitry we have according to the output is changed. Like there 1 condition were invalid, here 1 condition is not invalid, it will give output as Qn, means previous stage. There 0 condition were that were giving output as Qn, here 0 condition is invalid. So this is the difference between SR NAND latch and SR NOR latch. So thank you guys, thank you for watching this video, and I will continue this series, and I will try to upload daily 1 video at least. Sorry for the gap, because of some problem I have taken rest, and but now I will be continue. And thank you for watching the video. If you have any problem, I will give the mail ID. You can mail the question, or if you have any other doubt regarding this video lecture, so you can comment on comment section. Thank you.